Hello there and welcome to Science for Sleep. I'm really glad you're here. Maybe you're lying in bed with the lights off, maybe you're curled up in your favourite chair, or maybe you're just letting the day quiet down. However you've arrived, this is a calm little corner where you can rest, let go of the noise around you, and wander gently into ideas that are too big to rush. Tonight, we're going to wonder about something strange, something that hides in plain sight every second of your life. Time. You glance at a clock, and it's there. You feel it in the pace of your breath, in the sun rising and falling, in birthdays and seasons and calendars. Time is the invisible background music of everything. But what if it isn't? What if the universe could exist without it? What if, underneath everything we think we know, time is not a fundamental ingredient, but just a convenient story we tell ourselves? I know it sounds impossible, and yet some of the deepest theories in physics suggest that time might not be as real as it feels. Maybe it's more like the lines on a map. Useful, yes, but not actually drawn into the land itself. Before we sink into that idea, though, let me ask you something. What time is it where you are? Are you listening at midnight, the world around you quiet? Or is it earlier, maybe evening, maybe morning? Maybe that quiet space in between? You don't need to answer out loud, just notice it for a second, notice the hour on the clock, and then notice how quickly it slips away. Time has a habit of doing that. You look once and it's here, you look again and it's gone. Which is why tonight we're going to slow it down together, not because we can stop it, but because we can step back from it. And if this kind of quiet exploration feels good to you, if you like the feeling of resting while the universe unfolds like a soft story, feel free to give this a gentle like, maybe even subscribe. I read every comment you leave too, especially when you share where you're listening from. I love watching those little dots appear all across the world, like lights slowly coming on at night. So, take a slow breath, let your shoulders settle, and imagine something simple. No ticking clocks, no sunrises, no before, no after, just a universe without time. Could such a thing make sense? At first glance, it sounds like pulling the floor out from under reality. But what if reality doesn't need that floor at all? Let's begin at the most familiar place, how you experience time right now. You wake up and the day has a shape. Morning leads to afternoon, afternoon to evening, and you walk along that path like you're on rails. One moment follows another, always forward. But physics has a different view. In the deepest laws of nature, time isn't always there in the way you expect. The equations that describe gravity, the equations that describe quantum mechanics, they don't actually need time the way we use it. They describe patterns, relationships, changes. Time is something we add in afterward because it's the only way our brains can understand it. If that feels unsettling, that's okay. You're not alone in that feeling. Even Einstein had to unlearn his own sense of time to see the universe clearly. He discovered that time isn't absolute. It stretches, it bends. It depends on where you are, how fast you move, and how strong gravity is around you. Two people can live through different amounts of time and still meet again, which means time isn't universal, it's personal. And if it's personal, maybe it isn't fundamental. Maybe it's just one of the ways the universe keeps track of change. And if that's true, then there could be a deeper reality where time isn't needed at all. Imagine that for a second. A universe that simply is, all at once. Not flowing, not moving, not ticking, just existing. Every event that has ever happened or will ever happen could simply be there, like a vast landscape. You don't travel through it. You don't wait for it. You're simply in one part of it now, and later you might be in another. But the landscape itself doesn't change. This is hard to picture because every instinct you have is shaped by clocks and calendars and the way your heart beats. We live in time the way fish live in water. We don't notice it until we try to imagine being outside of it. But even if it's difficult, it's worth lingering on, because some physicists think that's exactly how the universe works. And here's where it gets even stranger. When you look closely enough at the building blocks of reality, the particles and forces that make up everything you see, time doesn't seem to appear in the math. The rules don't say, this happens, then this. They just describe relationships, how one thing depends on another, how pieces fit together. Time, in that view, is something we experience because we're not seeing the whole picture. Like a person standing very close to a painting, you see brush strokes, you see motion, but step back far enough, and suddenly the motion disappears. The whole image is there at once. If this is true, then maybe the question isn't, can the universe exist without time? Maybe the better question is, does time only exist because of how we look at the universe? And if we could step back far enough, if we could see it all at once, would we find that time has been an illusion all along? This doesn't mean your watch is lying to you. Time is still useful. It still runs your day. But it might not run the universe. It might be the way your mind turns something too vast into something you can live with. And in a way, that's comforting. Because if the universe doesn't need time, then nothing is ever really lost. Every moment could simply exist forever, quiet and unmoving, like pages in a book that never close, but we're not there yet. We're still moving slowly through this idea, and before we drift further, it's worth looking at how our sense of time first became flexible. Because there was a moment in history when time stopped being what everyone thought it was, and became something much stranger. And to understand that, we have to follow Einstein back to the beginning of his insight, where space and time became one thing, and once we see what he saw, we'll be ready to ask an even deeper question. If space and time are linked, what happens if time disappears? You've probably had this happen before. You're sitting somewhere quiet, maybe staring out a window, maybe just lying still, and suddenly you realize you've stopped paying attention to the clock. Minutes, maybe hours, slip past, and you don't notice until something pulls you back. For a little while, time didn't matter. You weren't counting it. You weren't chasing it. You were just there. That's the strange thing about time. Most of the time it feels like a constant presence, ticking forward whether you want it to or not. But the moment you stop looking at it, it starts to loosen its grip. When you stop tracking it, time feels different, softer, less mechanical. It's almost as if you're stepping out of it. Not in any literal way, but in the way your mind experiences it. Think about how it feels when you're deeply focused on something you love. Maybe you're reading, or listening to music, or just watching the sky change colour in the evening. Hours can pass like minutes. And then there are other moments, like waiting in line or staring at a screen when you'd rather be anywhere else, and every second feels stretched to breaking. Objectively, the clock moves at the same pace, but your experience of it doesn't. That alone should tell you that time, at least the kind you live in, is not as rigid as it appears. This isn't just psychology, it's also physics in disguise. Your brain isn't wrong for feeling time stretch or compress. It's responding to the way you interact with the world. And in the deepest laws of the universe, time is slippery in much the same way. It doesn't tick in perfect unison everywhere. It bends and shifts depending on speed, gravity, and perspective. Einstein showed us that if you could ride in a spaceship moving near the speed of light, your clock would run slower compared to everyone else's. To you, everything would feel normal. But back on Earth, decades might pass while you've only lived through a few years. Now, you don't have to travel anywhere near the speed of light to feel a hint of that truth. You've already felt it when you stopped thinking about time. It didn't stop, of course, but your experience of it changed because your mind was no longer measuring it in the usual way, and that tiny shift is a clue. If time can feel different depending on how you look at it, maybe it isn't as fundamental as we think. Maybe it's something that emerges from how we notice change, rather than something that exists on its own. Imagine, for a moment, that you could step completely outside the habit of measuring time. No clocks, no calendars, not even a sense of before or after. You'd still be here. The world around you would still exist. The stars wouldn't vanish just because you stopped counting the seconds. The universe doesn't check a clock to keep going. It simply is. What would that feel like? It's hard to picture because everything we know is framed by time, but if you let yourself think about it slowly, it starts to sound less impossible. There's an experiment you can do without even leaving your bed. Close your eyes for a while and pay attention to nothing in particular. After a few minutes, you'll notice that you lose track of how long you've been lying there. You might think it's been 5 minutes when it's really been 20. You might think it's been an hour when it's been 10. That's because your brain needs reference points, events, changes, markers, to know that time has passed. When those markers fade, so does your sense of time. Without motion, without difference, time slips out of focus. And in physics, that's exactly how many scientists think time itself may work. Some theories suggest that time is nothing more than a way to track change. If nothing changed anywhere in the universe, if every particle stayed perfectly still, every star frozen, every atom unmoving, there would be no way to tell that time was passing. Time and change might be two sides of the same thing. Take away change, and time might simply vanish. That's a strange idea, but it has consequences. It means that maybe time doesn't flow at all. Maybe it's our minds that flow, moving from one state to another, stitching together a sense of motion through a universe that is already there in its entirety. Some physicists call this the block universe, where the past, present and future are all equally real, all coexisting in a single vast structure. We just experience it slice by slice, like flipping through the pages of a book one at a time instead of seeing the whole story at once. And when you stop thinking about time, you almost get a glimpse of that. You stop flipping the pages quite so forcefully. You rest. You let the moments blur together. It's not that time goes away, it's that your awareness loosens its grip on it, and in that loosening, you come closer to what the universe might actually be doing. There's a quiet comfort in that thought. You don't have to control time. You don't have to rush to catch it or hold it still. When you stop trying to pin it down, it softens and you can almost feel the space beneath it. That space, the underlying reality, doesn't care if you're counting seconds. It's there whether you measure it or not. And maybe that's the first step to understanding how a universe could exist without time. You don't have to imagine everything suddenly stopping. You just have to imagine that time was never the engine running the show in the first place. Maybe it's more like the shadow of something else, something deeper. We're going to keep pulling on that thread. But before we do, think about this. The next time you look at a clock, remember that it isn't telling you what time is. It's only telling you what time looks like to a creature who has to move through it one moment at a time. If you could step back far enough, the clock might not be needed at all. And once you start to see it that way, you can begin to ask the next question. If time really isn't as real as it feels, what is it? And if the universe doesn't actually run on it, then what does it run on? If you've ever stared at a clock long enough, you know how convincing it can be. The steady tick, the orderly movement of the hands, the quiet certainty that one second follows another in perfect sequence. It feels unshakable, but that feeling is only a trick of perspective. The clock doesn't reveal time itself. It only measures change in a way that we've all agreed to call time. Think about what a clock actually does. It doesn't reach into the universe and grab hold of some cosmic thread called time. It just moves, its gears turn, its numbers change, your phone display updates, and because those changes are regular, we've built our entire understanding of time around them. But that's not the same thing as proving time is a fundamental feature of reality. It only proves that we've gotten very good at tracking motion, and motion is not time. You can take a planet spinning around its star, or an atom vibrating in space, or the swing of a pendulum, and you can build a system to count those changes. But if nothing moved at all, no planets circling, no hands ticking, no atoms vibrating, what would be left of time? Would it still be there? Or would it vanish, not because it was destroyed, but because it was never an independent thing to begin with? This is the unsettling part that physicists have been wrestling with for over a century. We've built our lives around clocks, but the universe doesn't seem to have one. Nowhere in the laws of physics is there a master clock ticking away behind the scenes. Einstein's equations don't describe a flowing river of time. They describe relationships between mass and space, between energy and motion. Time only appears when we step into the picture, when we impose a way of slicing up those relationships into a sequence that makes sense to us. If that sounds abstract, there's a way to see it more clearly. Imagine watching a movie frame by frame. Each frame is a frozen picture. On its own, it doesn't move. But when you play them in sequence, your mind turns those still frames into motion. You see a story unfold, even though every single frame already existed before you pressed play. Time, in this view, is the same kind of illusion. Every frame of the universe, the past, the present, the future, may already exist. Your mind is just watching them one after another, and calling it the flow of time. Clocks, then, are like projectors. They don't create time, they just pace out the frames. We take their pacing as proof that time is real, but all they're really doing is giving our minds a rhythm to follow. Without that rhythm, you'd still exist, the universe would still exist, and the structure of everything would remain unchanged. You just wouldn't have the same sense of moving through it. Even Einstein himself hinted at this. When his friend Michel Besso died, Einstein wrote a letter to his family saying, "For us convinced physicists, the distinction between past, present and future is only a stubbornly persistent illusion." He wasn't being poetic. He meant it. The math of relativity doesn't give any special privilege to now. From the universe's point of view, there is no universal clock striking a single shared moment. What's now for you might be later, for someone else moving at a different speed or sitting in a stronger gravitational field. Time is local, flexible, personal, and if it's personal, maybe it isn't the backbone of reality. But if clocks don't measure something fundamental, why does time feel so inescapable? Part of the answer is how our brains are wired. Our memory links one moment to another in a continuous chain. We don't remember the future. We don't feel the past. We live in a narrow window of experience, and that window creates the illusion that we are being carried forward. The ticking clock reinforces that illusion, like a metronome guiding a song that's already written. You've probably felt this illusion slip before. Remember those moments when you were so absorbed in something that you forgot time entirely? Maybe you looked up from a conversation and were surprised to see that hours had gone by. It's not that time sped up, it's that you stopped measuring it. You stopped flipping through the frames. For a little while you stepped out of the illusion. And this isn't just a philosophical trick. Physics points in the same direction. In quantum mechanics, the rules that govern particles at the smaller scales, time isn't fundamental. The equations that describe quantum states don't even need time to be written down. They only describe how one configuration relates to another. Time, in that view, is something we create when we stand back and compare those configurations. Without an observer to mark before and after, the math doesn't need time at all. It's hard to accept because it contradicts our instincts. We live by clocks. We wake up to alarms. We celebrate birthdays. We watch the hands move and believe we're moving with them. But from the universe's perspective, there may be no movement at all. Every tick of the clock might just be your way of walking through a landscape that's already there in full, unchanging and complete. And if that's true, it leads to a question that might be even stranger. If time is an illusion, why does it have rules? Why does it only move forward for us? Why do we remember the past and not the future? Why does every broken glass stay broken and never leap back onto the counter in one piece? For most of human history, time was simple. It was the same for everyone, everywhere. The sun rose, the sun set, and that rhythm was universal. It didn't matter who you were or where you stood. Time was the one thing you could count on to be steady, unshaken by the world around it. At least that's what everyone thought, until a quiet clerk in a Swiss patent office began to see it differently. Einstein didn't set out to dismantle time. He was trying to solve a much smaller puzzle. Physicists of his day believed that space and time were separate things. Space was where events happened. Time was when they happened. One was a stage, the other a ticking clock. But when Einstein began to look closely at how light behaved, he noticed something that didn't fit. No matter how fast you moved, no matter how you chased it or ran from it, light always travelled at the same speed. That single fact changed everything. If the speed of light never changes, then something else has to. And what Einstein discovered was that what changes is time itself. Imagine two people standing apart. One is still, the other moving quickly. Each carries a clock. You'd expect those clocks to tick in perfect sync. But Einstein's equations showed that they wouldn't. The moving person's clock would run slower compared to the one at rest. Not broken, not malfunctioning, just slower. And it wouldn't just be the clock. Everything about that person, their heartbeat, their thoughts, their entire flow of time would slow down relative to the other. This was not a small adjustment. This was a revolution. It meant there was no single universal now shared by everyone. Time wasn't a river carrying everything forward at the same speed. It was a flexible fabric, stretching and bending depending on how you moved and where you were. Two people could live side by side and experience time differently, and neither would be wrong. Einstein's insight didn't stop there. He realized that space and time weren't separate at all. They were one thing, spacetime, a single connected framework. You can't change one without changing the other. Gravity, instead of being an invisible force pulling objects together, was the bending of that fabric. A massive planet or a star pressed down on space-time, and everything nearby followed the curves it created. Even time itself bent around those curves. A clock on Earth ticks slightly slower than a clock far out in space, not because it's broken, but because gravity has changed the flow of time itself. If this feels abstract, you've already lived inside this effect without realizing it. Your feet are slightly closer to Earth's gravity than your head, which means, by an immeasurably small amount, time at your feet is running slower than time at your head. You don't feel it, but the difference is there. The same effect is so strong near a black hole that time for someone standing close to it would slow almost to a stop compared to the rest of the universe. What Einstein uncovered was that time isn't a fixed backdrop. It's part of the stage, and the stage can be stretched, tilted, and curved. The ticking clock is not a fundamental rhythm. It's a local rhythm, one that depends on where you are and how you're moving. This is why his work shook the foundations of physics. If time can change, then it's not the absolute universal thing we once believed it was. It's a feature of the way the universe arranges itself, a detail of the geometry of space-time. And if it's only a feature, then maybe it's not truly fundamental at all. Even stranger, Einstein's equations don't actually need time to flow. They don't describe a universe that evolves in the way we picture it. Instead, they describe a structure that simply exists. Past, present, and future are all laid out in that structure, like a map. You don't need a clock to describe the whole map. You only need a clock if you're walking across it, one step at a time, experiencing it from the inside. This is why many physicists now think that time, at least the way we experience it, might be a secondary effect. From a higher view, the universe could be timeless, a complete whole where what we call yesterday, today, and tomorrow all coexist. Your mind just moves through it in a single direction, and that motion creates the feeling of time passing. It's a radical idea, but it fits the math. And the deeper scientists have gone, from relativity to quantum mechanics, the stranger it has become. Some theories even suggest that at the most fundamental level, time might disappear entirely. Not because it's gone, but because it was never really there to begin with. But before we get to that, there's something we need to understand. If time isn't fundamental, why does it feel so unavoidable? Why does it seem to have a direction, always moving forward and never back? If you've ever stood by a river, you know how steady it seems. Water flows past and you can almost convince yourself it has no choice. That's how time feels most of the time. 1 second follows another, one moment leads into the next, and you never question whether it could do anything else. But in the strange language of physics, the river doesn't always flow at the same speed. Sometimes, in the quiet depths of the universe, it slows almost to a stop. This isn't a metaphor. It's one of the most confirmed effects in science. Time doesn't tick the same way everywhere. If you take a clock to the top of a mountain and leave another one at sea level, the one at the summit will run slightly faster. You won't notice it in any ordinary sense. Your life won't suddenly race ahead if you live at high altitude. But if you compare those clocks carefully enough, the difference is real. Time itself is moving at 2 slightly different speeds, and if you push that effect far enough, it becomes undeniable. Imagine hovering close to a black hole. From far away, someone watching you would see your movement slow down. Your voice would stretch out into silence. Your clock would almost stop. To you, everything would feel perfectly normal. You'd see your own hands moving, your own breath rising and falling. But in the outside universe, ages would pass in what felt to you like minutes. This is what we call time dilation. It isn't an illusion created by your mind. It's built into the structure of reality. Einstein's equations predicted it, and experiments have measured it. Astronauts on the International Space Station age a tiny fraction of a second less than the people on Earth because of their speed. GPS satellites have to account for time dilation, or their signals would drift and fail. Even your phone depends on a correction that quietly admits time is not absolute. If time can stretch like this, then it's not the constant background we imagine. It's more like a property of the universe that bends and adapts. And when you really think about that, something strange happens. You start to realize that the universe doesn't experience time the way you do. It doesn't have a single shared clock ticking in unison. It has countless local rhythms, each one tied to speed and gravity, each one its own little river. Stand next to a black hole and your river slows, drift out into empty space, and it speeds up. The universe contains all of these rivers at once, each flowing at its own pace, and yet they coexist perfectly. No argument, no contradiction, just a quiet, hidden flexibility. That flexibility has a calmness to it, because if time can run at different speeds, then your personal now is just one of countless ways the universe measures itself. It's not the universal present, it's just yours. Someone else, somewhere else, moving differently or feeling the pull of a different gravity, is living through a completely different stretch of time, and both of you are right. There's something almost peaceful about that. You're not racing against a single universal clock. You're moving through your own, and even that clock isn't fixed. It can be stretched, slowed, shifted by the weight of space itself. In the deepest parts of the cosmos, time practically comes to a halt. Near the edge of a black hole, a second for you could last forever compared to the rest of the universe. If that's possible, then the idea of time as an unstoppable river starts to look less certain. Maybe it's not one river at all. Maybe it's a network of streams, each one winding and bending depending on where it flows. And if that's true, then it's easier to imagine a reality where the streams vanish altogether, where the riverbed is dry, but the landscape, the universe itself, remains. This is where things begin to connect. If time can slow almost to nothing near a black hole, then there must be places or conditions where it doesn't exist at all. Some physicists believe this is exactly what happens at the deepest level of reality. Time emerges only in certain situations. The way temperature only makes sense when you're talking about trillions of atoms moving together. For a single atom, temperature doesn't exist. For the universe at its most fundamental level, maybe time doesn't either. But before we get there, it's worth pausing to consider what this means for the way we see the world. Every time you look at a clock, you're seeing just one version of time's flow. Every time you wait for something, you're leaning on a sense of time that is only local, only yours. Beyond that, in the larger universe, the river bends in ways you can't feel. It slows, it speeds up, and in some places it nearly stops. And if time can pause, even in that hidden way, then it's not hard to take the next step. What if it could vanish completely? If you think of your life as a string of moments, it feels natural to imagine each one being born and then vanishing as the next arrives. But what if none of those moments actually go anywhere? What if every single one of them simply exists? Fixed, unchanging, always there, whether you notice it or not. This is one of the strangest ideas to come from modern physics, but it's a serious one. In the deepest theories of the universe, there are no equations that say, this moment becomes the next. The math doesn't speak in terms of flow or motion. Instead, it describes structures, relationships between events, patterns that simply are. In that picture, what you call now is just one location in a vast landscape of moments. The past isn't gone. The future isn't waiting. They all exist at once, side by side, woven into a single, timeless reality. This isn't an easy thought to sit with because it's so different from the way you live. You wake up, you eat breakfast, you watch the sky shift from morning to night. It feels like movement. But that movement might not belong to the universe. It might belong only to you, the observer, walking through a static structure, like someone reading one page of a book at a time without realizing the rest of the pages are already there. Physicists sometimes call this the block universe. Imagine all of time laid out like a map. Every point on that map, every event, every moment already exists. You don't see the entire map because your consciousness can only stand in one place at a time. You call that place now, but the rest of the map is no less real. You've just not reached it yet. This view comes straight from Einstein's theory of relativity. In his equations, there's no master clock ticking away in the background. There are only relationships between events in spacetime. Your now is different from someone else's now, and there's no cosmic referee declaring which one is the true present. That means the universe doesn't privilege this instant over any other. All moments exist equally, even the ones you think of as long gone or yet to come. If this feels unsettling, you're not alone. It seems to erase the difference between past, present, and future. But it also solves a puzzle. If time were truly flowing, where would it be flowing from, and where would it be flowing to? If the future doesn't exist yet, how could you ever arrive at it? And if the past no longer exists, why can you remember it so vividly? The block universe sidesteps all of that. Nothing flows, nothing vanishes, nothing begins or ends. It just is. Now, you might wonder, if every moment exists, why don't we experience them all at once? The answer may lie in how our minds work. Your brain stitches together a sequence of events to create a story, because without that story you couldn't function. You'd be overwhelmed by a reality that contains everything at once. Instead, you experience a single slice at a time, and that slice feels like the present. From that perspective, time is less like a river and more like a spotlight slowly scanning across a stage that was already built in its entirety. There are even experiments that hint at this hidden timelessness. In quantum mechanics, particles don't seem to have definite positions or paths until we measure them. Between those measurements, the math that describes them doesn't contain any reference to time. The universe at its most fundamental level might not be ticking. It might simply exist as a network of possible states, all connected, with time appearing only when you zoom out far enough to see the pattern your mind expects. If that's true, then every moment, this one included, might be permanent. When you laugh at a joke, when you take your first step, when you look up at the stars for the very first time, those moments don't sink into nothingness. They remain. You've only moved on from them. This way of seeing the universe doesn't make time meaningless. It just changes what time is. Instead of a force carrying you forward, it becomes a way of navigating a landscape that's already there. The past doesn't disappear. The future isn't waiting. You're just walking from one fixed moment to the next. And if that's the case, it raises a question that's even more intriguing. If time is an illusion created by moving through these unmoving moments, what happens if you could step outside of that motion entirely? What would you see if you could stop and look at the whole structure at once? Not just one moment, but all of them. When you think about the universe expanding, it's natural to picture galaxies rushing through space, as if they were running across a stage. But that's not what's happening. Space itself is stretching. The galaxies aren't flying apart because they're moving through some empty container. The container itself is growing. Distances widen not because things are travelling, but because the very fabric of reality is unfolding beneath them. This idea alone is strange enough, but it leads to an even deeper question. If space can stretch, can time be left behind? We tend to link the two so tightly that it's almost impossible to separate them. Einstein's work tied space and time together into one single thing, spacetime, where changes in one affect the other. When mass bends spacetime, it bends both space and time. When you move faster through space, you move slower through time. They are woven together, inseparable in the way we usually imagine the world. And yet, the universe seems to play by rules that don't always match our intuition. Space can expand. We've watched it happen. Distant galaxies drift farther and farther from us, not because they are moving through space, but because there's more space between us. And this expansion doesn't require anything to happen to time itself, at least not in the way we experience it. Time doesn't visibly stretch when the universe grows. Your seconds don't get longer just because a galaxy billions of light years away is receding faster than you can imagine. This suggests something subtle but powerful. Space and time are tied together, but not always in the way we think. Space can evolve, grow, change in size, while time seems to be something we experience locally, in the middle of it all, as if we're standing still while the cosmic fabric stretches around us. Now imagine taking that to its limit. What if the universe could exist without time altogether? What if what we call time is only a local property? The way temperature only exists when many molecules move together. A single molecule doesn't have a temperature. It has energy, yes, but temperature is a word that emerges when enough pieces interact. Maybe time works the same way. Maybe it isn't fundamental. Maybe it's something that only appears when matter and energy arrange themselves in certain ways. There are theories in physics that treat time exactly like this. In some approaches to quantum gravity, the attempt to unite quantum mechanics with Einstein's spacetime, time disappears from the equations entirely. What's left is a description of the universe in terms of relationships, not motion. Things don't happen in order, they just exist in relation to one another. The before and after that you and I depend on aren't there. And if those theories are right, then time is something like a shadow cast by space and matter. When the universe is dense and structured, the shadow looks clear and steady. But if you were to peel it back to its simplest, most fundamental state, the shadow would vanish, and with it, time. Space would still exist, stretched, curved, and structured. But without the ticking clock we experience inside it. This might sound like a contradiction. How can space expand if there's no time to expand into? But that question only exists because of the way we're used to thinking about change. In a timeless universe, expansion wouldn't be something that happens. It would simply be part of the universe's structure. The universe wouldn't grow. It would simply be big, with that size built into its very nature. And what we see as growth would only be our way of walking through that structure one slice at a time. This is hard to picture, but not impossible. When you look at a map, you don't see a road getting longer as you trace it with your finger. The road was always that length. You're just following it. In the same way, space might not be stretching in time. It might simply be what it is, and time is nothing more than the way we experience our journey across it. If this is true, then it brings us closer to something remarkable. A universe where time is not the stage but a perspective. Not a thing that exists on its own, but a way of looking at something deeper. When we talk about the universe, we almost always talk about it in terms of beginnings. We picture a moment when everything started, an instant when the first light appeared, when time itself began to tick. The Big Bang is the story we're told, and in many ways, it's the best story we have. But what if it isn't the whole story? What if the universe didn't begin at all? It's a strange idea because our minds are built on sequences. You wake up, then you eat, then you move through your day. One thing follows another, and you can't help but imagine the same is true for everything, even the cosmos. If there's a now, then surely there must have been a before. But the laws of physics don't share that intuition. They don't need a beginning. In some of the deepest theories we have, the universe doesn't start. It simply is. The Big Bang, in this view, wasn't the first moment of time. It was just one feature in a much larger structure. Time, as we experience it, might emerge only inside certain conditions that didn't exist before the universe cooled and expanded enough for clocks, change, and sequences to make sense. Outside of that, there may be no before and no after. This isn't just speculation. In quantum cosmology, there are models where the universe is timeless. All of space, all of energy, all of the moments you could ever point to exist in a single, unified whole. We only perceive a beginning because we are trapped inside one thin slice of it. From our narrow perspective, the Big Bang looks like the start. From outside, it might simply be one region in a much larger map, no more the beginning than the middle of a circle is its start. Even Einstein hinted at this in his later work. He imagined a static universe, one that didn't require time to move forward in order to exist. Though his version of the cosmos was later replaced by the expanding universe we now accept, the idea that the universe might not need a true beginning never disappeared. Modern physics keeps circling back to it because every time we peel back another layer of reality, time itself starts to fade from the picture. And if there was no beginning, there may also be no end. Heat death, the collapse of stars, the fading of galaxies, all of these things might happen within the slice of reality we see. But in the larger structure, the one that contains every moment equally, nothing is ever truly lost. Every star that burns out still exists in its own place. Every moment in your life remains. The universe isn't erasing them. You're just walking past them. This view changes everything. It means the question, what happened before the universe, might be meaningless. Not because there's no answer, but because before doesn't exist at the fundamental level. It's like asking what's north of the North Pole. The question dissolves when you see the whole shape. If that's true, then maybe the universe doesn't need time to explain itself. Maybe time is only a way for us to navigate what was always there. And if that's the case, then the Big Bang was not a beginning. It was simply the point where the part of the universe we inhabit became visible to us. This way of thinking might feel unsettling, but it's also strangely calming. If there was no true beginning, and there will be no final end, then the universe is not rushing toward anything, or away from anything. It is simply there, complete, unchanging in its totality while we move through it. But there's still a question left hanging in the air. If the universe is timeless in this deep sense, how do we explain the way we feel time moving? Why do we remember yesterday but not tomorrow? What gives time its direction, if not some cosmic clock? If you've ever watched a clock in a quiet room, you can almost hear it speaking. Each tick is small, precise, certain. But in the world of the quantum, that certainty disappears. Time itself seems to lose its voice there. It doesn't tick. It doesn't march forward. In fact, it becomes something far stranger, something that might not exist in the way we think at all. At the smaller scales of reality, the rules change. Particles don't move from point A to point B like little marbles on a table. They exist in clouds of probability, spread out as if they're in many places at once until you look. And here's the part that unsettles everything. The equations that describe this quantum world don't need time. They don't say, first this happens, then this. They describe relationships static and timeless. One of the most striking examples is the Wheeler-DeWitt equation, an attempt to bring quantum mechanics and general relativity together. It has no time variable at all, none. It treats the universe as if every possible state already exists simultaneously, and what we call time is just a way of looking at it from inside, not a property of the universe itself. In this view, the flow of time is like a story we tell ourselves while flipping through the pages of a book. The book doesn't change just because we're reading it. The pages are already there. The only thing moving is our place in the story. Quantum mechanics suggests that, at its foundation, the universe might be exactly like that. A static whole, where what we experience as the present is just the page we happen to be on. This isn't just theory. Even experiments hint at it. In quantum entanglement, two particles can be separated by light years, but when you measure one, the other responds instantly, as if distance and time don't matter at all. It's not that information is moving faster than light. It's that, in the quantum view, both particles are part of a single timeless system. There's no before or after between them. They simply are. This is why some physicists argue that time isn't fundamental. It emerges only when you zoom out, the way temperature emerges from countless molecules bumping together. At the quantum level, time may vanish, replaced by a kind of raw, unstructured reality. You only feel the ticking clock when you step back far enough for the world to look familiar again. It's almost unsettling, but it also fits. The deeper we dig, the more time slips through our fingers. Classical physics gave us time as a steady backdrop. Einstein showed us it could stretch and bend. Now quantum mechanics whispers that it might not even be there at the bottom. What we experience could be no more than a reflection of how we, as observers, interact with this underlying timeless structure. And yet, if time isn't there at the quantum level, why does it appear so convincingly in our everyday lives? Why does the universe look so ordered, with one thing happening after another, with a past we can remember and a future we can only imagine? This is where the boundary between the quantum world and the world we see every day becomes important. Somewhere between the two, time reappears. Not as something the universe truly has, but as something that emerges when enough particles, enough interactions, and enough complexity come together to give us a sense of sequence. It's not time that creates change. It's change that creates time. If that's true, then time is nothing more than a tool our minds use to make sense of a universe that doesn't actually need it. And if that's the case, then the universe can exist perfectly well without time. It already does, beneath everything you see. But that brings us to another strange corner of this story. Because if time vanishes at the smallest scales, what happens to it in the strangest places in the universe? Places where gravity bends reality so far that the very concept of before and after starts to break apart? If you want to see where time begins to break down completely, you don't have to look at the smallest particles. You can look at the largest objects in the universe, black holes. These strange, silent giants don't just warp space. They stretch time until it almost disappears. Imagine falling toward a black hole. From far away, someone watching you would see you slow down. Your movements would become sluggish. Your clock would tick more and more slowly. As you reach the edge, the event horizon, you would appear to freeze. From the outside, time for you would come to a halt. You'd be trapped on the edge forever, suspended in a single moment that never seems to end. But from your own perspective, nothing unusual would happen. You'd keep falling. You'd cross the horizon. You wouldn't feel time stop. It would be everyone else, far away in the universe, who would seem to speed forward without you. This is the paradox of black holes. They divide reality into two viewpoints, both equally valid, both completely different. Time isn't absolute. It bends until the word almost stops making sense, and it gets stranger. Inside the event horizon, the very roles of space and time switch. Moving forward in time becomes as inevitable as falling deeper into the black hole's center. You can't resist it. There's no turning around. In a sense, time inside a black hole isn't something you experience anymore. It becomes a direction, a path you can't escape, like sliding down a slope that only goes one way. For physicists, this isn't just a curiosity, it's a clue. Black holes take the flexible time of Einstein's relativity and push it to its limit. If time can slow to nothing at a black hole's edge, then maybe it was never fundamental to begin with. Maybe black holes are showing us the skeleton of the universe, the place where time is stripped away to reveal something deeper that doesn't depend on it at all. Even the horizon itself adds to this mystery. It's not a physical surface, it's a boundary drawn by the rules of spacetime. Cross it, and no signal can ever come back out. But for someone far away, that boundary looks like the edge of time itself, a place where moments stack up and never move forward. If you could stand there and look at it, you'd see the last moment of anything that fell in, held in suspension for eternity. And beyond that horizon, we don't know. General relativity says there's a singularity at the center, a place where our current understanding collapses. Quantum physics suggests there might be no singularity at all, just a different kind of timeless region, one where space and time stop being meaningful concepts. Some scientists even argue that what happens inside a black hole could be a key to understanding the universe itself, because if you can explain why time breaks there, you might explain why it exists anywhere else at all. This is why black holes are more than just cosmic oddities. They're natural laboratories for the deepest questions in physics. They show us what happens when time is pushed to the edge of existence, and in their silence, they might be telling us that the universe doesn't need time to be what it is. But black holes aren't the only places where time fades. Beyond their event horizons, in the first fractions of a second after the Big Bang, and in the quantum fabric beneath everything, the same pattern keeps appearing. Time is not fixed, it is not universal, and in the most extreme conditions it might not exist at all. If that's true, then we're left with a strange conclusion. Time might only be a convenient story that applies to where we are, at the scale we live in, with the conditions we know. Step outside those conditions, whether at the edge of a black hole or at the foundation of the universe itself, and the story unravels. The question now is what that means for us. Because if there are places in the universe where time doesn't exist, then maybe time isn't the rule. Maybe it's the exception. And if that's the case, we need to ask what reality looks like when you stop treating time as the thing that keeps it all together. If you could rewind the universe, not just back to the first stars or the first atoms, but all the way to the very beginning, you might expect to find time itself ticking faster and faster, counting down to that first instant of creation. But what if, instead of speeding up, it stopped? What if at the earlier stage, before the universe as we know it began, there was no time at all? This isn't just a thought experiment. In some of the most advanced theories in physics, the early universe wasn't just tiny and hot, it was timeless. The equations that describe the universe at its smallest scale, before it began expanding, don't include time as a variable. Instead, they describe a kind of static quantum state, a frozen hole with no before and no after, no motion, no change. It sounds strange, but it's not without precedent. In quantum mechanics, particles don't move in the way we normally think. They exist in superpositions in many states at once, until something, an interaction, a measurement, forces them into a definite outcome. The universe, at its very beginning, may have been something like that, a vast, timeless superposition, containing every possibility at once, waiting for something to break the symmetry and create what we now call time. When cosmologists talk about this, they sometimes describe the early universe as being in a quantum foam, or a wave function of the universe, a state where time doesn't apply, Nothing changes in this state because there is no before or after to compare. It's as if the universe was holding its breath, not yet moving, not yet flowing, not yet dividing itself into the moments we now experience. Only later, as the universe began to expand and cool, would time as we know it have emerged, like a pattern crystallizing out of something that was once completely still. Some researchers even compare this to how temperature only appears when many particles come together. A single particle doesn't have a temperature. It's only when you have an enormous collection of them interacting that hot and cold become meaningful. In the same way, the earliest universe may not have had time. Only when it grew and became structured enough for change to take shape did time switch on. This means that asking what happened before the Big Bang might not make sense at all. If time itself didn't exist, there was no before for anything to happen in. What we think of as the beginning might simply be the point where time first became meaningful, where a timeless state gave way to the familiar ticking sequence that governs our lives. It's an unsettling picture because it erases the idea of a starting line. The universe doesn't spring out of nothing in a single explosive moment. Instead, it emerges smoothly, naturally, out of a state where nothing was moving and nothing needed to move because there was no time to measure motion in the first place. If this is true, it reshapes the way we think about everything. It means time is not a fundamental feature of the universe, but a byproduct of its growth. It didn't exist until there was something for it to measure, and if it had to emerge, then it's not unreasonable to think it could also vanish again, leaving behind the same kind of timeless state that may have existed at the start. This idea isn't just abstract theory either. Physicists working on quantum gravity and cosmology use it to build models of the early universe that fit what we see today. The ripples in the cosmic microwave background, the faint afterglow of the Big Bang, may be the fingerprints of this transition, from timelessness to time. So if the universe began in a state where time didn't exist, and if time only later emerged as a feature of the expanding cosmos, it leaves us with an extraordinary possibility. The universe doesn't need time in order to be real. Time is something we experience because of where and how we exist, not because it is built into the foundation of everything. But if time can switch on, could it also be something that switches off? Could there be places, even now, where time is absent, the same way it may have been in the beginning? Places not at the edge of the universe, but here, hidden in the deep structure of reality, where change doesn't happen and the ticking of the cosmic clock goes silent. When you think about the future, you probably imagine something open, unwritten, still waiting to happen. The past is fixed, the present is now, and the future hasn't arrived yet. It feels obvious. But according to one of the strangest and most widely discussed ideas in physics, that might not be how reality works at all. This idea is called the block universe. And in this view, the future isn't something that happens later, it's something that already exists. Einstein's theory of relativity opened the door to this perspective. In relativity, there's no single universal now that stretches across the universe. What's happening for you right this moment might be in someone else's future, or in someone else's past, depending on how fast they're moving or where they are. That means there's no cosmic line dividing past from future. All moments are equally real. They simply exist in different places in space-time, like different locations on a map. Imagine holding a book in your hands. Every page in that book exists at the same time. The page you're reading now feels like the only one that's real, but the other pages aren't waiting to be written. They're already there. You'll get to them eventually, but they don't spring into existence when you turn the page. They've been there from the start. In the same way, the block universe suggests that every moment, yesterday, today, tomorrow, exists all at once, laid out in a four-dimensional structure. You're just moving through it, one page at a time. This view changes everything about how we think of time. It means that the future isn't a blank space waiting to be filled. It's as real as the past. You just haven't reached it yet. And if that sounds unsettling, it's worth remembering that this is a natural consequence of physics as we know it. Nothing in Einstein's equations picks out a special now. The laws of nature treat all of time the same. In this framework, time doesn't flow. There's no universal clock ticking forward. Instead, what we call the passage of time is simply the way our minds experience movement through this unchanging structure. We don't notice the other moments because our consciousness can only focus on one slice at a time. This idea even offers a new way of thinking about memory. We remember the past not because it's gone, but because it's the part of the block we've already moved through. The future feels unknown not because it doesn't exist, but because we haven't reached it. From outside the block, from a perspective beyond our experience, there would be no difference between them. Every moment would be equally real, sitting there in the fabric of space-time, unmoving and eternal. Of course, this raises difficult questions. If the future already exists, does that mean everything is predetermined? Are our choices illusions? Some physicists and philosophers argue that even if every moment is fixed within the block, the experience of making decisions is still part of the structure. The act of choosing, the sense of freedom, is just as real as any other event. The block doesn't erase it, it contains it. This perspective can be unsettling, but it can also be strangely comforting. If every moment already exists, then nothing is ever truly lost. The happiest day of your life, the people you've loved, the quiet evenings you thought were gone, they're still there, woven into the structure of the universe. You've only moved past them, but they remain. And if that's true, then the same must be true of the future. Somewhere in the block, every step you'll ever take is already part of the whole. You don't have to worry about catching it. It's already there, waiting for you to arrive. But there's still a deeper question hiding inside this idea. If time is just a dimension of the block, and if all moments exist at once, why do we move through it in one direction? Why don't we experience the future the way we experience the past? Why does time, even in a timeless universe, still feel like it has an arrow pointing forward? If the universe is a vast block of moments, each one already there, then why does your life feel like it's moving? Why do you feel yourself changing, aging, and living through time instead of simply existing in it? The answer may be that you're not just living in one kind of time, you're living in two. The first is cosmic time, the time of physics, the one measured by the ticking of atomic clocks and the bending of space-time. This is the time that satellites rely on, that GPS systems must correct for, and that astronomers use to track galaxies moving billions of light years away. It's objective, impersonal, and governed by the laws of relativity. The second is biological time, the time you carry inside your body. You can feel it in the beating of your heart, the rise and fall of your breath, and the rhythm of your sleep. It's in the gradual changes of your cells, and in the subtle way your body keeps track of the day even without a clock. Unlike cosmic time, biological time is deeply personal. It's tied to memory, perception, and the physical processes that make you who you are. These two times don't always match. In cosmic time, you might be hurtling through space at incredible speeds without ever noticing. In biological time, a moment of fear or joy can stretch out endlessly, while an hour spent in boredom feels like it lasts forever. Your body's time is elastic, bound not to the precise equations of relativity, but to the way you experience life. Even more fascinating, cosmic time and biological time interact in subtle ways. Astronauts who live aboard the International Space Station experience time just a tiny bit slower than those of us on Earth because of their speed and position in space. Their bodies age imperceptibly differently compared to ours. In a way, they're living in slightly different slices of cosmic time, even as their biological clocks continue ticking along in the only way they know how. And yet, no matter where you are or how fast you move, your body's time is always grounded in the same familiar rhythm. You sleep, you wake, you grow older. Your brain knits these changes into a story, and that story gives you the sense of moving forward through a universe that, from a larger perspective, may not be moving at all. Biological time is what makes the arrow of time feel real. This arrow isn't written into the laws of physics. The equations of relativity work just as well if you run them backward. But your body, like everything else made of matter, is tied to entropy, the slow increase of disorder in the universe. This is why you remember the past but not the future. It's why broken things don't put themselves back together. Your biology is a one-way process, unfolding inside a universe that, at its deepest level, might be timeless. When you think about it that way, you can see why your sense of time feels so strong. It's not just the ticking of a clock, it's the sum of everything your body does, from the growth of your cells to the way your brain weaves moments into memory. Without this biological layer, you might not feel time passing at all. You'd simply exist, like everything else in the block universe, without ever noticing that you were in motion. But this dual existence, cosmic time on one side, biological time on the other, creates a fascinating tension. It means that while the universe may be timeless as a whole, your personal experience of it is built entirely around change. You live in the part of the picture that moves, even if the larger picture never does. And that might be the reason time feels so precious. It isn't a fundamental feature of the universe. It's a feature of you. You carry it with you everywhere, and it shapes the way you see everything else. But there's another layer to this, because if your body can experience time differently from the universe, what happens in the one place where your sense of time naturally fades away almost completely, where minutes and hours blur and the ticking of the clock loses its grip? That place isn't out in deep space or at the edge of a black hole. It's much closer. It's the world you enter every single night when you sleep. Every night, without thinking about it, you step into a world where time almost stops. You close your eyes, and the familiar rhythm of seconds and minutes fades away. Hours pass, but you don't notice them. You might dream, and in those dreams, entire stories unfold. Yet when you wake, you can't say how long any of it lasted. This is the strange way your brain escapes time in sleep. Sleep is not just rest, it's a shift in how you experience reality. When you dream, your brain doesn't keep time the way it does when you're awake. The clocks in your head, the ones that keep you anchored to the present moment, lose their grip. A dream can feel as if it lasts for days or only seconds, and there's no reliable way to measure the difference. Your mind doesn't care about the ticking of the clock. It isn't bound to cosmic time or even biological time in the same way. It slips into something else, something closer to timelessness. This isn't just a poetic way of describing dreams. Neuroscientists have found that when you sleep, the brain networks responsible for tracking time become quiet. The parts of your mind that keep track of duration and sequence take a step back. Instead, the brain focuses on weaving images, sensations, and fragments of memory into something that feels continuous but isn't measured against any external standard. And that's why dream time feels so strange. You can live an entire lifetime in a dream. You can walk through cities that never existed, have conversations that last for what feels like hours, and then wake to find that only a few minutes have passed. Your brain isn't counting seconds. It's building a world where seconds don't matter. In this sense, sleep is one of the closest experiences you have to a universe without time. You still exist. Your thoughts still move, but they move without the rigid frame of before and after holding them in place. You don't wake up in the middle of a dream and wonder what time it is. You only do that when you return to the waking world, where the clock rules again. This nightly escape hints at something profound. If time can lose its hold on you so easily, if your brain can function in a state where time is irrelevant, then maybe time isn't as essential to consciousness as it feels. Maybe it's just one mode of perception, one way of organizing experience among many. This also explains why sleep feels so restorative. For a few hours, you're not just resting your body, you're stepping outside the relentless push of time. You're slipping into a state where there is no rush, no countdown, no constant awareness of the clock. And when you wake, the return to time can feel abrupt. as though you've rejoined a current that was always there, but that you'd been floating above for a while. It's worth noticing how similar this is to what physics tells us about time itself. Beneath the surface in the quantum world, there is no ticking clock. Time emerges only when you zoom out far enough to see it. In a way, your mind seems to do something similar. When you dream, it stops tracking time at the scale you're used to. It drops into a lower level where time simply isn't part of the picture. But then you wake up, you look at the clock, and without thinking, you step back into the steady rhythm of seconds and minutes, as if nothing happened. It's only when you pause to consider it that you realize how strange this is, that every single night you pass through a world without time and come back without even noticing the transition. And maybe this is another clue. If your mind can so easily exist without time, even for a few hours at a stretch, then maybe time really isn't the unshakable foundation we think it is. Maybe it's something you use, not something you are. If you've ever stood on a mountain and looked down at the valleys below, you've felt gravity's pull in the most ordinary way. But what you might not realize is that gravity isn't just holding you in place. It's quietly changing the way time passes for you. Einstein's theory of general relativity revealed something extraordinary. Gravity doesn't just bend space, it bends time. The stronger the gravity, the slower time moves. It's not a trick of perception or a limitation of your senses. It's real. If you lived your entire life near the surface of a massive planet, your clock would run more slowly than the clock of someone living far above you, where gravity is weaker. You wouldn't notice it. Your heart would still beat at the same rhythm. Your days would still feel the same length. But compared to someone far away from that gravitational field, you would age just a little bit more slowly. Time itself, for you, would have been stretched. We've tested this. In experiments using highly precise atomic clocks, scientists have measured the difference in time between clocks separated by just a few feet of height. The clock closer to the ground, where Earth's gravity is slightly stronger, runs infinitesimally slower than the one higher up. The difference is small, but it's there, written into the fabric of space-time. This effect becomes even more dramatic near massive objects like black holes. There, gravity bends space-time so severely that time slows almost to a stop. If you stood near the edge of a black hole while someone else remained far away, they would watch you move in slow motion. Minutes for you might become centuries for them. From their perspective, you'd appear frozen on the brink forever, while the rest of the universe raced ahead. And yet, from your point of view, nothing would feel unusual. Your seconds would pass normally. This is one of the strangest things about time dilation in gravity. Every observer's experience is self-contained. No one ever feels time slowing down for themselves. You only see it when you look at someone else, when you step outside your own local clock and compare it to another. This means there is no single master clock for the universe. There are only countless local times, each shaped by gravity. A clock on a satellite in orbit runs faster than one on Earth because it's farther from our planet's gravity. GPS systems must correct for this, or their calculations would be hopelessly inaccurate. Every piece of technology that depends on precise timing is, in its own quiet way, a reminder that time is not absolute. If time can be stretched this way, it's hard to keep thinking of it as something fundamental. A universal, unchanging flow wouldn't bend under gravity, but time does. It adapts to the shape of the universe, to the curves of space-time itself, and in some places, those curves push it nearly to zero. It's in those extremes, near black holes, in the early universe, and deep inside the equations of physics, that we begin to see what might really be happening. Time isn't the foundation, it's a side effect. Gravity shows us this clearly. As space bends, time bends with it. Like a shadow that moves because something deeper is shifting underneath. And if that's true, then maybe time doesn't define reality. Maybe it's the other way around. The shape of reality defines time. When the shape changes enough, time itself almost disappears. This realization is a quiet one, but it changes everything. Because if time depends on gravity, then it's not hard to imagine a universe, or even regions within our own, where gravity's influence or the absence of it makes time meaningless. And that leads us to an even stranger question. If gravity can slow time down until it nearly stops, what would it mean to live outside of time altogether? Not in theory, but in the way physics seems to suggest is possible in certain places at the edge of reality. If you try to imagine what it would feel like to live outside of time, your mind almost immediately runs into a wall. We're so used to measuring life in seconds, minutes, and years that it's almost impossible to picture an existence where none of those things apply. But physics keeps pointing us toward a reality where time might not be fundamental, and if that's true, then there must be a way to at least glimpse what it would mean. Start by stripping away everything you normally associate with time. No clocks, no sunrises or sunsets, no aging, no before or after. What's left isn't empty. It's still the universe. The stars would still exist. Matter and energy would still be there. But without time, nothing would change. There would be no motion, no cause and effect, just a complete and unmoving whole. This isn't science fiction. It's what many theories of physics actually describe at the most fundamental level. In the equations of quantum gravity, there's no time variable. The universe is treated as a single, timeless object, with every possible state it can have existing simultaneously. In this view, time isn't something the universe has. It's something that emerges only when you look at it from the perspective of someone inside it. If you could step outside of that perspective, you wouldn't see events unfolding. You wouldn't see the universe happening. You'd see everything at once, every moment that has ever been or ever will be coexisting like points on a vast map. There would be no need to move from one moment to the next because every moment would already be there. From our point of view, this is almost impossible to imagine because our experience of life depends entirely on change. We feel time because our bodies change, because we remember the past and because we anticipate the future. Remove those things, and what's left wouldn't feel like life at all. It would be something entirely different, a state of pure existence without any sense of passage. And yet, in a strange way, you already brush against this idea every day. When you sleep deeply and wake up with no memory of the night, hours pass, but it doesn't feel like they did. It's as if you jumped from one point to another without crossing the space between. For you, those hours didn't exist. That's not what living outside of time would be like, but it's a hint. It shows how easily your mind can skip over the experience of duration and simply be in one moment, then another, without feeling the movement between them. If time really is something that emerges rather than something that's fundamental, then living outside of it wouldn't mean floating in darkness or nothingness. It would mean being in a state where everything simply is. No waiting, no moving forward, no sense of loss because nothing can ever be lost if all moments exist forever. This is why some physicists and philosophers see this idea not as something frightening but as something strangely peaceful. If the universe at its deepest level is timeless, then everything that has ever happened and everything that ever will happen is woven into it permanently. Nothing vanishes, nothing is erased. We only experience it one piece at a time, because that's the only way we can. But if that's true, then it raises a new question. If time isn't fundamental, and if reality might be timeless underneath, why do we experience time the way we do? Why do we live in this one-way flow instead of seeing everything at once? The answer might not be that time is an illusion, but that it's a kind of lens, one that turns a timeless universe into something we can live in. And to understand that lens, we need to look at what happens if we push this idea even further. What if time stopped entirely, not just for you, but for the whole universe? Would anything actually change? If time suddenly stopped, what would you expect to happen? Maybe you imagine everything freezing in place, the planets halted in their orbits, waves paused in mid-air, and every thought in every mind suspended. But if time really did stop, there wouldn't be a moment for you to see it. There wouldn't even be a you to notice. That's the paradox. When you take time away, change disappears with it. Motion, memory, and cause and effect only make sense inside time. If time stopped, nothing would happen, not even the stopping. The universe wouldn't freeze. It would simply be in a state that has no before and no after. This is one of the reasons physicists argue that time isn't a fundamental feature of the universe. It's not that there's a cosmic clock that could run out or suddenly halt. Time doesn't seem to exist independently at all. What we call time might only be our way of keeping track of change. Take away the changes and you don't just stop time, you remove the very need for it. You can see a shadow of this idea in the mathematics of physics. The equations that describe the universe don't need a universal ticking clock to work. They only describe relationships, how one thing depends on another, how matter and energy interact. When nothing changes in those relationships, time becomes irrelevant. It simply falls out of the picture. Even your own experience supports this in small ways. Think about the moments when you've lost all sense of time, maybe while staring at the sky, maybe while drifting towards sleep. Time didn't really stop, but your awareness of change became so faint that it almost felt like it had. In those moments, you weren't counting seconds. You were simply existing, and nothing seemed to move. This is why, if time were to stop in the deeper sense, nothing would actually feel different. There would be no feeling at all. A timeless universe wouldn't be empty or dead. It would be complete. Everything would exist simultaneously, every event, every detail, but there would be no motion through it, no frame after frame, no story unfolding, just the whole, all at once. And this isn't just speculation. In some theories of physics, especially in quantum gravity, this is exactly how the universe is described. Time doesn't appear in the equations. The universe is treated as a static object. What we call the flow of time isn't something the universe is doing. It's something we experience because we're inside it. We're moving from one part of that static whole to another, and our minds translate that motion into a story. If you removed that story, if you could step outside of it, you wouldn't see time stopping. You'd see that it was never running in the first place. And if that's true, then asking what happens if time stops might be like asking what happens if you turn off the light in a room full of objects. The objects don't vanish. You just stop seeing them the way you used to. This isn't an ending. It's another shift in perspective. Because if nothing would change if time stopped, then time might not be the foundation we've always believed it was. It might be a convenient way for us to move through something that was never moving at all, and if that's the case, then we need to take one more step. Because there's an idea that builds on this, one that many physicists and philosophers quietly agree on, that the only thing we ever truly have is the present, not because the past is gone or the future isn't real, but because every moment is part of a single, eternal now. If you've ever sat quietly and felt a moment stretch until it seemed to hold the whole world in it, you've brushed against an idea that both philosophers and physicists have been circling for centuries. The idea is simple. The only thing that truly exists is now. From the perspective of physics, this comes from relativity. There's no universal now, no single slice of time shared across the universe. What you call the present depends on where you are and how you move. Two people in different places can disagree on what now even means, and both can be right. That alone is enough to suggest that the flow of time is not fundamental. It's a matter of perspective. Philosophers have been saying something similar for much longer. For them, the present isn't just a fleeting point between past and future. It's the only place anything ever happens. You can't live in the past. You can't stand in the future. All you ever actually touch is this single, continuous moment. And here's where science and philosophy quietly meet. In some interpretations of modern physics, the universe isn't flowing from one moment to the next at all. Every event, every heartbeat, every star igniting, every word you'll ever speak exists at once, embedded in the fabric of space-time. From outside of it, there is no past, no future. There's only a single, eternal structure. What we call now is just the point where our awareness happens to be. This doesn't mean the past is gone or the future isn't real. It means they're both as real as this instant. You just can't stand in all of them at once. Your mind is a traveller, and the present is the path it takes. But the path is already there. You're not carving it out of nothing. You're following it. Strangely, this idea isn't bleak. It's comforting. If every moment exists forever, then nothing is ever truly lost. The laughter of a child, the warmth of a single afternoon, the stars you saw on a clear night, all of it still exists, written into the universe as unshakably as the laws of physics themselves. You've simply moved past those places, but they're still there. And if the future is also part of this eternal structure, then it's not rushing toward you like a wave you have to outrun. It's already waiting. Every step you will ever take is already there, part of the whole, just as unshakable as your past. This is the eternal now. It's not a moment that passes. It's the entire universe seen all at once. Philosophers reached it by reflection. Physicists reached it by math. And both perspectives meet in the same place. The realization that time, as you experience it, is only one way of looking at something much bigger and far quieter than the ticking of any clock. But there's one more step we can take. If the universe is already complete, if every moment exists in an eternal now, then maybe you don't need to hold on to time at all. Maybe it's enough simply to rest in it, to exist in this slice of infinity, knowing that nothing is ever lost and nothing ever truly ends. And that brings us to the final thought that ties all of this together, not physics, not philosophy, but the simple, human way of living in a universe that doesn't need time at all. If everything we've explored is true, if time is not fundamental, if every moment already exists, if the past and future are as real as the present, then we're left with a choice. Is the universe without time, or is the universe nothing but time, stretched out in its entirety, waiting to be seen? These two ideas sound opposite, but in a way they might be the same. When physicists describe the block universe, they talk about time as if it's laid out like space, a dimension that doesn't move but simply is. From that perspective, there is no flow, no ticking clock, no universal now. But that doesn't mean there's no time at all. It means the universe might be made entirely of it, a vast structure of every moment, every change, every event existing together in one unbroken whole. If that's true, then time is not something that passes, it's something that is. The future doesn't arrive any more than a distant mountain suddenly pops into existence when you walk toward it. It was always there, you just couldn't see it yet. And yet, from our perspective, this doesn't feel like a static universe. We live inside time as if it were a river. We measure it, we chase it, we feel it moving around us. That feeling might only be the way consciousness travels through this larger structure, one point of awareness sliding along a dimension that never changes. But even if the universe is timeless at its core, time is still what we see from the inside. This is why the question isn't easy to answer. To say the universe has no time would be true from one point of view, but to say the universe is made of time, of every moment that ever was or will be, might be just as true from another. The difference isn't in the universe, it's in how we experience it, and that brings us back to something important. If every moment already exists, then the universe is not rushing toward anything. It's already complete. You're not racing against time. You're simply walking through a reality that, from a higher perspective, is already finished. But for you, here, inside it, time still matters. It's what gives shape to your life. what lets you experience the story one moment at a time instead of being overwhelmed by the entire thing at once. It's the reason you can remember yesterday and dream about tomorrow. Without that, existence might be too vast to even understand. So maybe the universe is both timeless and made of time, depending on how you look at it. From outside, it's silent and still. From inside, it moves and breathes and unfolds, and both views, impossible as it seems, can be true at once. If that's the case, then you don't have to choose. You can live in time without being trapped by it. You can imagine the timeless whole without needing to leave the present. You can let the two ideas exist side by side, the way physics and philosophy so often do, each one pointing toward a universe that is far stranger and far quieter than the ticking of any clock. After everything we've explored, the bending of time near black holes, the timeless quantum world, the block universe where every moment exists at once, it's tempting to think that understanding time will change how we live inside it. But the truth is simpler. You don't need to solve time, you only need to feel it. Because no matter how strange the universe may be, no matter how many theories point to time being an illusion, this moment is still here. You're breathing. Your heart is beating. The world, in its quiet way, is still unfolding around you. You don't have to reach back into the past or forward into the future to find something real. It's already here, in the present, waiting for you. If time is a landscape, you don't have to see the entire map to walk the path in front of you. If every moment exists, you don't need to hold on to the ones that came before or rush toward the ones that are still ahead. They're already there, safe in the structure of the universe. All you have to do is take the step that's in front of you now. And maybe that's the point. Physics can strip away the illusion of time, but it doesn't erase what it feels like to live in it. In fact, it can make each second feel even more precious, because if every moment is already eternal, then this one, the one you're in right now, isn't going anywhere. It's yours, whether you notice it or not. So take a breath. Let yourself feel the weight of this instant without trying to stretch it or shrink it or trap it in your hands. You don't need to fight time. You don't need to solve it. You only need to rest in it, the way the universe has been resting in every moment since the beginning, if there even was a beginning. All of this, the timelessness of physics, the endlessness of space, the quiet truth that every moment exists forever, leads to one simple conclusion. You don't have to understand time to be at peace with it. You only have to live in it, one breath, 1 second, one present moment at a time. And that's enough. Because even if the universe doesn't need time, you do. Not because it's real in the way you once thought, but because it gives you a way to move through the infinite without being overwhelmed by it. A way to simply exist here, now, while everything else, past and future alike, waits patiently, as it always has, and as it always will. So let it wait. You're already exactly where you need to be. And that's where we'll leave it for tonight. We've wandered through black holes and the quantum world, past the illusion of clocks and into the idea that every moment, past, present, and future, might already exist, resting quietly in the universe's timeless structure. Whether time is an illusion, or the very thing the universe is made of, it doesn't change this. You are here, in this moment, and that is enough. You don't have to solve time. You don't have to hold on to it. All you need to do is let it carry you, softly, one breath at a time. If this journey helped you drift a little deeper into thought, or maybe even into sleep, I'm glad. And if you'd like to keep exploring these quiet corners of the universe with me, you can always join me again. There's always more to wonder about and no rush to get there. So for now, close your eyes if you haven't already. Let the world outside grow quiet. Let this moment stretch, slow and unhurried. Time will take care of itself. You just rest. Good night, and I'll see you in the next one.